Let's go to Solika 382 linked list random node. For this question, give us a singly linked list. And let's return a random node's value from the linked list. Each node must have the same probability of being chosen. So return this kind of node's value. We need to implement a get random. So intuitively, what we're thinking about is that we iterate this kind of linked list twice. The first time we iterate from the head to the tail and get the total counts of the linked lists, total counts of nodes. For example, there are 1,000 nodes. Then we use a random function to get the random number from 0 to 1,000. And then we use this kind of index to iterate from the head to this index again to get this node and return its value. So that is the simplest approach. But you say it has follow-up. What if the linked list is extremely large and its length is unknown to you, right? So if it is very large, for example, it has a billion, or those kind of counts. If we iterate twice, it will be so what we want is that we should iterate as few as we can, right? So what we do is that we should have some beta approach. Possibly we can iterate once. So how can we implement this kind of approach by iterate once? Right? There is a method called reservoir sampling. So the approach, the algorithm to do this is that we iterate from the head, right, to the next about the linked list. And every time we use a variable called count or scope, right? So initially this scope is set as 1, right? So the things that when we iterate, we have our cursor point to the head, right? So when this cursor moves to the next node, we have a scope increased by 1. And for every time we move to a next node, we have a random, we get a random number from 0 to 1, right? So if this kind of random number is smaller than 1 over scope, then our result, right, we just set this kind of node's value. So we know the scope is the counts we from the head to our current, right? So this is 1, this is 2, right? So the so that means that we actually we do this. We set values when this is smaller than scope 1 over scope before this scope increase, right? So that we so we, for example, we move to this kind of we currently is set at the current as head, right? So we'll say initially it's 100% because the scope over 1 over scope is 1, right? And our random function is from 0 to 1. So 100% is set as the V0, right? And let's go to next. And this one has, when we come here, right? So if we use this kind of random function again, this scope is going to increase as 2 right now. So it has a 1 over 2 possibility to be chosen the second one. And if this has been chosen 1 over 2, right? The previous has a possibility to be 1 minus 1 over 2 to be kept, right? So each of that have a 1 over 2 possibility. So we're doing like this, right? We iterate from the head to the tail, right? So the last one, the scope has become 1 over n, right? So as long as this random function is smaller than 1 over n, then we have the value to be the last one, right? So we know this one has a possibility 1 over n, right? Let's talk about the general case. So when we iterate to the i's node, right? So it has a 1 over I possibility, the result to be set as Vi, right? And for I plus 1, it has 1 over I plus 1's possibility to set as V plus 1, right? That means we have, if we already have goes to the node I plus 1, we have 1 over I multiplied by 1 minus, that is 1 minus 1 over 1 over I plus 1, right? To be kept with the value Vi to be kept, right? So that means you'll see if we have I plus 1, right? So that this one has also 1 over I plus 1. And until we go to the I plus 2, it has a 1 minus 1 over I plus 2 possibility to be kept, right? So until we go to the last one, it has a 1 minus 1 over n possibility, the i's value to be kept. So if we look at this formula, it's 1 over I multiplied by I minus I plus 1, multiplied by I plus 1 over I plus 2, and multiplied by A minus 1 over N, right? So that is, so for the i's nodes, the possibility, probability to be kept is 1 over N as well, right? So that we have this kind of criteria, then we don't need to iterate twice. We just have this kind of criteria that when we during the iteration, we we have the possibility to update our final result. So let's write code for this. We'll have a list node head, set this dot head equals head. We know we need a scope variable, right? And set as 1, result initial set as 0. What we do is that we have cursor, it's the node current equals this dot head, right? What we do is that while this current doesn't equal to none, then current equals current dot next, right? Return result. Right? So during our iteration, we need to, of course, when we move, right, we should have a scope should increase by 1, right? We should do this during our moving our cursor moving to the next. We do this. So we'll say if we have a random function mass dot random is smaller than 1 over scope. Let's just change this to double. Then we have this kind of possibility to be result equals current dot value. So doing like this, mass random. For every node, it has 1 over n's possibility to be chosen. Python code, let's try Python code as well. So we also have a self dot head equals head. Then what we do is that we are going to have a scope variable, right? And the result. And then we'll have a current cursor point to a head. And scope initial set as 0. Result you can set as anyone. And this will be dot self dot head. Then we'll say, why this current is not none, right? So we'll have current its current dot next, right? During our move, we'll have our scope. Every time we should increase by 1, right? So what we do is that if random dot random smaller than 1 over scope, then we're going to have a result equals current dot value. In the end, we just return result. Self head. So while current random smaller result equals doing like this, let's see the time complexity, right? It just will be still be ON, right? Because we are going to move from the head to the tail, right? Space is constant.